Listen. For decades, the search for intelligent life has rested on a quiet assumption. If the universe is this old and this crowded.
But what if that assumption is wrong? What if the universe isn't silent because life is rare, but because it's far away?
Not unreachable because of secrecy or hostility, but because of distance itself.
Tonight, we're exploring what that separation really means. Not as a number.
Before we if you enjoy counter universe UFOs.
Because the real question may no longer be whether we're alone, but whether anyone could ever be close enough to know. On Earth, distance feels negotiable. A few hours of travel connects cities. A day connects continents.
The galaxy does not agree.
The Milky Way is roughly 100,000 light-years across, containing hundreds of billions of stars, spread through.
From our position about 26,000 light-years from the galactic center, even our own galaxy is only partially visible.
Light from distant regions takes longer to arrive than human civilization has existed. In that context, 33,000 light-years is not a minor separation. It is not a neighbor.
It is nearly a third of the galaxy's diameter.
Any message sent from such a civilization would arrive long after the society that sent it had likely changed beyond recognition, if it still existed at all.
This reframes the search for extraterrestrial intelligence in a profound way.
If the closest technologically advanced civilization is that far away, then the galaxy is not a crowded neighborhood. At these scales, proximity loses meaning. Nearby stops being a useful concept.
The silence, then, is not mysterious. It is structural. But biology and astrophysics suggest the opposite.
Life does not emerge under simple or uniform conditions.
Stars form throughout the Milky Way, but not all regions are equally hospitable.
Peripherals. The galactic center is dense, chaotic, and radiation-heavy, with frequent supernovae and strong gravity.
The outer regions of the galaxy are quieter, but poorer in heavy elements needed to form rocky planets.
Somewhere between these extremes lies a broad, imperfect zone, where conditions are more favorable.
Even within that zone, suitable planets may be rare. Stable orbits, long-lived stars, protective magnetic. Then biology must emerge, persist, and survive extinction-level events for billions of years.
Intelligence, if it arises at all, must do so late, after countless evolutionary contingencies align. Technological intelligence narrows the odds even further.
A species must not only evolve intelligence, but also develop tools, language, cumulative knowledge.
It must avoid self-destruction long enough to broadcast detectable signals into space.
When these filters are combined, intelligence may not appear frequently or evenly. It may. If this is the case, then civilizations do not cluster the way stars do. They are not drawn together by gravity or chemistry. They emerge independently, scattered across the galaxy. 33,000 light-years is not an anomaly in that scenario.
It is exactly what randomness looks like at galactic scale.
Even if technologically advanced civilizations exist, and even if they are aware of one another's potential presence,
A radio transmission crossing 33,000 light-years arrives 33,000 years after it is sent.
by that time, civilizations may have transformed, collapsed, or disappeared entirely.
This creates a deeper symmetry in awareness.
The message becomes an archaeological artifact rather than a conversation. Contact turns into discovery, not dialogue.
The speed of light does not merely slow communication. It fragments history.
It ensures that civilizations experience the galaxy not as a shared present, but as a layered archive of ancient moments. Even if intelligence is common, simultaneity is rare.
This may explain why the search for extraterrestrial intelligence feels so lonely. We are listening for signals that may no longer be alive.
We are broadcasting into a future we will never see.
The silence, then, is not evidence of absence.
It is evidence of distance.
The idea that the nearest technologically advanced civilization may be tens of thousands of light years away.
It emerges from statistical models that combine what we know about stars, planets, biology, and time. Then remove assumptions that once felt comforting, but were never guaranteed. Modern estimates begin with the structure of the Milky Way itself.
Some regions formed early and violently, others slowly and quietly.
Then there is the matter of technological lifetimes.
A civilization capable of broadcasting detectable signals does not remain in that phase forever.
Technology changes, communication methods collapse.
The period during which a society is both advanced and visible may be brief compared to cosmic timescales. When these factors are folded together, the result is not a galaxy humming with overlapping signals, but one. Even if many exist across the Milky Way's history, very few are likely to overlap with us right now. Fewer still would be close enough for their signals to arrive within a meaningful time frame.
Distance in this framework is not just spatial, it is temporal.
A civilization 33,000 light-years away is also 33,000 years away in time.
That separation compounds uncertainty, turning proximity into a fleeting coincidence rather than an expectation. What feels shocking at first becomes almost inevitable once the assumptions are stripped away.
The galaxy may host intelligence, but it does not arrange it conveniently.
Stars in different parts of the galaxy form at different times, under different chemical conditions, and with different probabilities of hosting habitable planets.
Life, if it arises, does so independently. Intelligence, if it follows, emerges late and unpredictably. There is no synchronization mechanism ensuring that civilizations appear together.
The result is a galaxy composed of isolated moments rather than shared experiences. One civilization may rise and fall while another is still microbial. Another may flourish long after Earth has gone silent. Even if the total number of intelligent societies is large across billions of years, their overlap is minimal. This breaks the intuition that the universe should feel crowded.
The Milky Way does not guarantee either.
From this perspective, the search for extraterrestrial intelligence has always been aimed at a moving target.
We are listening for echoes from distant times and distant places, hoping that
The fact that it may not is not a failure of imagination, but a
Remember, 33,000 light years is not a sign that intelligence is rare.
Even if a civilization exists far away, and even if it transmits powerful signals, those signals do not travel intact.
They weaken as they spread, dissolving into background noise long before crossing the galaxy, unless they are deliberately focused and continuously maintained.
Radio waves disperse.
Accidental leakage from technology, which once seemed like a promising sign of nearby intelligence, becomes irrelevant across galactic distances.
This means detection requires intent.
That decision must also coincide with our own listening efforts. The alignment required is extraordinary.
Meanwhile, technology on Earth has already begun to change in ways that reduce our own visibility.
Excuse me, what is this called?
That is dragon fruit.
It's very good.